Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
So, it's kind of hard to ignore how AI is popping up like everywhere, isn't it? From, suggesting shows to watch to healthcare, finance, even logistics. It feels like it's really moved beyond just buzz.
Absolutely.
Yeah.
The potential has been talked about for ages, but what's really happening now is seeing it actually work in so many different areas. The real trick, though, and what we're digging into today, is how you actually build these things reliably.
Exactly. And that kind of leads us right here. We're not necessarily getting lost in like the super complex math today. Instead, we want to talk about something maybe more fundamental, AI engineering.
That's it.
And specifically, a core part of that, designing these things called functional models.
Yeah, think of it like you could have the most amazing AI model, right?
Yeah.
Like a superpowered engine.
Okay.
But without a solid chassis, clear plans, a good team put it together, that engine isn't actually going anywhere useful. AI engineering gives you that structure. And the functional model, that's your starting blueprint.
Gotcha. So our mission for this deep dive, then, is to really get under the hood of these functional models, figure out what they are, why they're so essential for building AI that actually, works.
Right.
And we're basing this on a really great piece from AI World Journal, From Concept to Code, Engineering AI Applications with Functional Models by Ann Schultz. So let's start at the top. What is AI engineering, practically speaking?
Well, basically, AI engineering is taking, solid engineering principles and applying them to AI systems. It's not just about training models, which is what maybe most people think of first.
Right, there's more to it.
Oh, much more.
Right.
The article really lays it out. So the whole life cycle starts with system design, the big picture architecture.
Yeah.
Then data management, huge aspect. Where does the data come from? How's it handled?
Okay.
Then, training and evaluating the models, obviously. But also deploying them, scaling them up, monitoring how they're doing, getting feedback.
So making sure they actually run properly in the real world.
Exactly. And crucially, things like security, ethics, governance. It's the whole package.
The article had a good analogy for this, didn't it?
Yeah.
Something about a bridge.
Yes, exactly. Called AI engineering, the bridge between data science experiments and reliable production-grade software. You might have brilliant data scientists doing amazing research.
Right, in the lab.
In the lab, yeah. But AI engineering is what takes those successful experiments and turns them into stable, scalable tools people can actually use safely, reliably, moving from prototype to dependable product.
I like that bridge idea. Makes it very clear. Okay, so within that bigger picture of AI engineering, we're zeroing in on functional models. What exactly is a functional model?
So the article defines it as a conceptual framework. Basically, it maps out how the AI system processes information, from the very start, the inputs, all the way to the outputs. And it does this by breaking the whole system down into logical blocks.
Testable blocks, like different steps in the process.
Precisely. It's like a high-level flowchart of the system's architecture. You're not worried about the specific code just yet, or even the exact algorithms. You're focused on the flow of information and the main jobs that need to be done.
Okay, so a kind of blueprint for the AI's thinking.
That's a good way to put it, yeah. A blueprint. And this blueprint then guides everything else, the detailed design, the coding, and really importantly, how you test the whole thing.
Right, so it's the plan before you start building. But why is that so important? Why not just, dive in and start coding the AI?
That's a key question. And the article gives some really solid reasons. First off, it's a blueprint for development. Simple as that. Having that architecture clear before anyone writes code means everyone's on the same page. Gives clear direction. Imagine building complex furniture with no instructions at all. It's going to be wobbly, right?
Huh. Yeah, probably fall apart. Okay, that makes sense. What's another big reason?
Second thing is cross-team communication. This is huge. AI projects usually involve lots of different people, right? Data scientists, software engineers, maybe business folks, domain experts.
Different languages, almost.
Exactly. They all have different perspectives, different jargon. The functional model gives them a common language, a shared picture of how the system should work. It avoids that situation where, the plumbers and electricians on a building site have totally different plans.
Right. Prevents wires crossing, literally and figuratively. Okay, so better communication. What about when things go wrong, like debugging?
That's the third big win, debugging and testing. Because you've broken the system into these clear, logical blocks. It's way easier to figure out where a problem is. If the output's weird, you can look at the functional model and say, okay, is the issue in the preprocessing block or the NLP model block?
Yeah.
You can isolate it. Much easier than digging through one giant mess of code.
Like a well-labeled circuit board. Makes tracing problems easier. Okay. And the last point was about scalability.
Yeah, scalability, because functional models push you towards modularity. Designing things in separate connected blocks means you can often update or replace one block without messing up the whole system. Need to improve one part's accuracy, just work on that block. It also means you might be able to reuse some of these blocks in totally different AI projects later. Saves a ton of time.
Okay, those are definitely strong points for starting this way. So the article gives a 7-step process for actually using these functional models to build AI. Let's walk through that. Step 1.
Define the objective. Seems obvious, but probably critical.
Absolutely critical. Yeah, the article really hammers this home. You have to start with a super clear idea of the problem you're solving. What's the goal? Detecting defects in photos, analyzing customer tweets for sentiment, recommending articles. Getting that objective clear up front dictates everything else. It's your North Star for the whole project.
Like knowing what cake you want to bake before grabbing ingredients. Okay, step 2. Step 2 is design the functional model. This is where you actually draw it out. Sketch the logical flow. What are the inputs? What steps? What transformations need to happen? What should the final output look like?
And the article had that AI document summarizer example, right? Can you walk through that one?
Sure. So for the summarizer, the input is just, text, a document.
Right.
That text goes into a pre-processing block, cleans it up, maybe removes junk, gets it ready. Then it hits the NLP model, that's natural language processing, the AI part that understands the text.
Okay.
The output from that goes to a summary generator block, which takes the key info and boils it down. And finally, you get the output, the short summary.
Yeah.
See? Input, NLP summary, output. A clear flow.
Yeah, you can really visualize the journey of the information there. Okay, step 3, collect and prepare data. That sounds tightly linked to the model you just designed.
Directly linked. Once you have...
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Have that functional model, you know exactly what kind of data you need for each block to do its job and how it needs to be formatted. The article mentions common prep steps: tokenization, breaking text into words, labeling, tagging data, normalization, getting data on the same scale, feature extraction, pulling out the important bits for the model. The functional model tells you what prep is needed so the data flows right.
So the blueprint tells you what materials you need and how to cut them. Okay. Step 4, choose and train models. This is where the algorithms finally show up.
Exactly. Now you pick the specific machine learning models for each block's job. Like the article says, maybe transformer models for tech stuff, convolutional neural networks for images, gradient boosted trees for tabular data.
Right, different tools for different tasks.
Precisely. And you use tools like TensorFlow, PyTorch, Scikit-learn Crayon. Those are common frameworks to actually train these models on the data you prepared. You're training each model to do its specific part of the overall flow defined by the functional model.
Okay, got the plan, got the data, models are trained. Step 5, build the system around the model. What does that involve?
This is a really important point the article makes. The AI model itself, it's just one piece. You need to build all the stuff around it to make it work in an application.
Like the support structure.
Exactly. These like APIs, application programming interfaces for getting data in and out, processing pipelines to manage how data moves between the blocks, data storage, maybe a user interface if people interact with it directly. It's building the whole car around the engine, essentially.
Right, the plumbing and wiring to make it useful. Then step 6, test the functional flow. Quality control time.
Super important. Yeah, before you let this thing loose, you test the whole flow end to end. The article suggests using mock data, trying to simulate real-world inputs, including weird edge cases.
Trying to break it.
Kinda, yeah. Ask things like, does it behave as expected? Are the outputs actually accurate and useful? What happens if it gets weird or missing data? Catching bugs here before deployment saves a lot of headaches.
Definitely better to find problems in the lab. Okay, last step, number 7. Deploy and monitor.
Right, so you've tested, you're confident. Now you package it up, Docker is mentioned, cloud tools, and deploy it. AWS, GCP, Azure, wherever it's going to live. But crucially, it doesn't stop there. You have to monitor it constantly, track its predictions, see how it's performing, gather user feedback, and plan for continuous learning, retraining the model with new data over time so it stays accurate and relevant. It's an ongoing cycle.
So not a one-and-done thing at all. Build, test, deploy, monitor, refine, repeat. Okay. The article also gave that cool AI-powered health assistant example. How did the functional model look for that?
Yeah, that was a neat illustration. It started with symptom input, which was text from the user.
Okay.
That went into an NLP parser to understand the language and pull out the key symptoms. Then a medical knowledge graph lookup, basically querying a big medical database.
Right.
Based on that lookup, a diagnosis suggestion engine figured out possible conditions. And finally, a response output gave the suggestions back to the user.
Input.
Input, parse, lookup, suggest, output.
You can really see the modules there. Like, you could update the medical database without messing with the language parser.
Exactly. That's the beauty of it.
Yeah.
The article pointed out benefits like easily adding data from, say, wearable devices, updating the medical knowledge continuously, even personalizing suggestions based on the user's history. Starting with that functional model makes it accurate, scalable, and user-friendly.
Okay. And then there was that table comparing the traditional way of building ML with this functional model approach. What were the big takeaways there?
Yeah, that table was really clear. On development clarity, traditional is often ad hoc, unclear, while the functional model approach is high-level structured. Big difference.
Right from the start.
For testing, traditional is often post-hoc, done after the fact. Functional models integrate testing in the design itself. You're thinking about testing from day one.
Much more proactive. What about teamwork?
Collaboration in traditional setups can be fragmented. Different teams might not have a clear shared picture. Functional models give that unified understanding. Everyone works off the same blueprint.
Makes sense.
Scalability. Traditional systems might need rework to scale. Functional models are modular by design, so scaling is often easier, just upgrading or adding blocks. And finally, debugging. It can be hard to isolate issues in traditional systems, but the clear logical blocks of a functional model make finding problems much simpler.
Wow. Okay. So across the board, clarity, testing, collaboration, scaling, debugging the functional model approach seems to have some pretty significant advantages. It sounds much more like, well, engineering.
That's exactly the point the article drives home. AI engineering and using functional models specifically isn't just a nice idea anymore. It's pretty much vital if you want to build AI apps that are reliable and actually make an impact.
Yeah, the message seems to be start with that functional model. It gives you a clear, scalable, testable plan for success.
Right. And it specifically called out, startup founders, engineers, product managers, saying this approach helps speed things up, keeps teams aligned, and lowers the risks involved in building complex AI.
And that final quote was pretty memorable, too. In the fast-evolving world of AI, structure matters, and the functional model is your foundation.
Yeah, sums it up perfectly. You need that structure to move from cool AI ideas to dependable tools people can actually use. Functional models provide that foundation.
Okay, so quick recap then. Functional models are these high-level blueprints, mapping out how an AI processes information in logical steps. Using them is key to good AI engineering because it brings clarity, helps teamwork, makes testing and debugging easier, and boosts scalability.
You got it. It's the framework needed to turn AI concepts into real-world value, reliably.
So for you listening, maybe think about AI projects you know of. Could be at work, could be something you read about. How might thinking about them through this functional model lens change how you see their development or their potential issues? Something to chew on.
And the article did mention next steps, like trying to build your own first functional model, or looking out for examples like chatbot blueprints. While we aren't providing those directly here, it shows this is a practical approach people are actively using and refining.
Definitely. Which brings us to a final thought for you to consider. We see AI weaving itself into more and more parts of our lives, right? Some small things, some really critical systems. How might this engineering-focused approach, using functional models as that base, impact the actual reliability and, maybe even more importantly, the trustworthiness of the AI we're all going to depend on more and more?
That's a big question. Definitely something to think about.
Indeed. Well, thanks for joining us for this deep dive.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.